everyone. Our project is feature-based reinforcement learning for solving the 2x2x2 Rubik's Cube. Our team members are myself, Devi Kamampati and Kavya Bobineni. In this project, we combine supervised learning, reinforcement learning, and a search method to build a system that can solve any scrambled 2 into 2 into cube. Our solver uses three main ideas. First, a supervised deep cube A model predicts how many moves the cube is away from being solved. Second, a DQ and reinforcement learning agent tries moves, gets rewards, and learns which moves are helpful. Finally, a search algorithm uses the model's predictions to explore cube states that look promising. Together, these methods allow our system to reliably find solution paths. Moving to the system architecture, the system has 5 parts. We represent the cube using only its 8 corners so that the state is small and easy to work with. The deep cube A model estimates distance to solve, and the DQ and agent learn moves values from the experience. And the search algorithm expands the cube states that appear closest to solve. All these parts connect together to turn a scrambled cube into a solid one. And moving to the cube structure, the cube has only 8 corner cubes. Each corner has a position and an orientation and stores these values for all corners fully describes the cube. Because it has around 3.6 million states, it is a small enough for machine learning techniques. I will now pass the presentation to my friend Kavya who will take it from here.
Let's now look at the supervised deep cube model. Here we generate scrambled cube states and label them with how many moves were used to scramble them. The deep cube model learns to predict that number, and the predicted value becomes our heuristic for guiding the search. We'll now have a look at the reinforcement learning. The DQN agent interacts with the cube, chooses moves, and gets rewards. It stores each experience and learns which moves bring the cube closer to be solved. Because solving gives a reward and each extra move gives a small penalty, the agent learns to find the shorter solutions. Our solver uses the best first search algorithm, which expands states predicted to be closer to solve. A priority cube helps choose the next best state, and we avoid revisiting of the states. Even with an imperfect heuristic, this method always finds a valid solution. Now let's look at the scramble fix and the solver improvements. To ensure realistic scrambles, we avoid moves that cancel each other and avoid repeated moves. This prevents easy or accidental solved scrambles and makes the solver consistent. The output provided are the solver prints the scramble depth, scramble sequence, solution path, number of moves used, and also the time taken. This helps us evaluate how well the system is performing. Overall, our hybrid system solves the 2 into 2 into 2 Rubik's Cube by combining supervised learning, reinforcement learning, and heuristic search. It learns from the data, improves moves, quality with RL, and uses the predictions to search the guide. And yeah, in simple terms, the code works like this. We install the required libraries, generate training data, train the supervised model, train the reinforcement learning agent, and finally run the solver, which prints the scramble and also the solution path. I have given the command to solve the sol.py file, and the solver has started and it has just printed the scramble depth, which is 6, and also the scramble sequence has been printed, where it denotes L for left, B for back, F for front, R for right, D for down, and B for back again, and etc. And here is the solved puzzle. The number of moves used were 53, and the solution path is been printed, and also the total time taken is also been printed. Thank you.